how are we doing? Generally there? Not that complicated. Oop. So where do we have? We started with something like this one. Number 1 was income doubles. What happens? So you just double your intercepts, each of these, and the curve's twice as far out. What's number 2? Was coffee goes up. Price of coffee goes up. What happens there? Intercept for coffee goes from 2.5 to 2. Donut stays the same, so this intercept stays the same, and the slope changes a little bit. What's the third one? Is price of donuts goes up to the same as price of coffee. And what happens there? Anybody help me out? Y-intercept changes to here, so we're something like that. You probably did a much better job drawing your lines than myself. I need to figure out the digital ruler. OK, that was all straightforward. That was 1. Did I do something wrong?
There was 2.5 was marked there, so.
Oh, so I would have had a place to go. OK. So now we're going to talk about what people prefer to do. So we've got the budget constraint down. We have a map of what is possible, what you can afford. But then we have people's preferences. What could they prefer to do? What would they want to do? What would they want to consume? So demand theory, people have preferences subject to constraints. People maximize utility subject to constraint. That's the nugget of demand theory right there. So that's going back to just bundles, your different bundles. A and B are bundles. And so in our A and B, we have our vector x1, x2. So there are different combinations. We have these bundles that are the vectors of the two quantities. And we assume that all consumers can rank the bundles. They can always tell you which bundle they prefer to another bundle, which I know is not true for me. I have this problem all the time. But we're going to assume that everybody has a clear and transparent ability to rank bundles. Either A is preferred to B, or B is preferred to A, or you're indifferent between A and B, which is me because I can never decide. But so different people are going to have different rankings. And later we're going to aggregate people. We'll get demand curve. But in each individual demand, people could rank things in different ways. Some people really don't like donuts. Some people don't drink coffee. So a bunch of abstractions again. There's two groups. There's two goods that are totally different, totally identifiable, totally describable. You would want to consume more of each one. And you would know in some way how you want to balance the two of them. So this is like a bunch of assumptions that's going into ranking preferences between bundles. You know the two goods. You know how much you would want to consume of them in combination. Obviously, there's a whole bunch of overreach here. People consume what's bad for them. People have addictions. People are not rational consumers. People consume things that harm other people. So there's externalities to yourself. There's externalities to other people. Obviously, in my example, as somebody brought up last time, donuts are bad for you. This picture is of the donut bacon sandwich, which is just kind of freaky, but people are really into it. It's like the rage sweeping the East Coast. We have a lot of obesity increasing in the country. We have a lot of diabetes. We have both obesity and diabetes that are officially at epidemic levels now. So you don't want to eat more of these things as income increases or price goes down in the general demand sense that we do. Here's our obesity rates. The United States is quite a bit higher. Supposedly Mexico is up there with the United States, but this is other OECD countries. So we have a huge amount of obesity. And we also have this sort of runaway diabetes. So this is what you could say from the chapter 3 thing, a market failure for health. We have billions of dollars that we're going to spend dealing with diabetes. We have a whole lot of people's utility that's cut back. People's welfare is worse off because of this. And it's still just pushing up. So this is a caveat to my promoting donuts in class. Anyways, assume people have meaningful preferences. This is economics in general. We're going to assume people have preferences that make sense to them. We're going to assume away addiction, mental health, irrationality. We're going to assume away this market failure for people's health. We're going to start with this market case of people being able to rank bundles rationally. So these are just, always remember in the background that many of the assumptions of economics are a little crazy, but we need to make things make sense mathematically first, and then we can look at market failures afterwards. So we have some properties of preference ranking. We have increasing ordinality, so more is better in our indifference curves and in our ranking. If bundle A has more of one good and no less of a second good to bundle B, then A is preferred to B. So if you have two goods and one has two bundles and one has more of either of the goods, then it would be preferred. And I'll just show where that comes in the mapping. Also, there's transitivity. If A is preferred to B and B is preferred to C, then A is preferred to C. So just standard mathematical properties that are going to make our curves make sense. And if A is preferred to B, then B is not preferred to A. So these are just like logic foundations that we're setting up so that we'll have indifference curves that make sense. So if we have a bundle, quantity of good 1, quantity of good 2, I'm going to do A, B, and C for our bundle still. This more is better is that any bundle that has more of good 1 or more of good 2, this is good 1, this is good 2, would be preferred. And anything that has less of the 2 is not preferred, which gives us 2 of the quadrants here. In this quadrant, we don't know, and in this quadrant, we don't know yet till we have an indifference curve, but we don't know mathematically. We know anything in this quadrant will be preferred, anything in this quadrant will be not preferred. So if we have our bundles over here, bundle A, bundle B, bundle C, and we have the property of A is preferred to B, and B is preferred to C, then A is preferred to C. Pretty standard mathematical properties. So bundles are ranked in an ordinal way. This is back to just ordinal versus cardinal. We only need to know how we rank the bundles. We don't measure utility. So the fundamentals of demand theory are consumers maximize utility subject to a budget constraint, but we don't actually have a measure of utility. We just have a way to say which x's are preferred to which other quantities of x's. It's an ordinal ranking of utility. So indifference curves are graphically where a consumer is indifferent between two different bundles. So if you start with point A, there's an indifference curve that goes through point A of all of the other points at which the consumer is indifferent to point A, bundle A. Another way to say this is a level set. Yep. We will get more. What do you want to say? right, I can go back to it, but we'll do it hopefully more. So here's another version of it. So this is the quantity of good 2. This is the quantity of good 1. And so from this point, we would prefer any point into here because it has more.
Oh, A is already a bundle?
A is already a bundle that we already have, and we're trying to rank different bundles.
Okay, that makes sense.
You'll see, I'll belabor the point enough that you'll be bored with it soon. So our indifference curves, a level set. This is back to the contour lines. The topographic map, here's a nice old map of campus. Yeah, I told you I like maps. So we have contour lines. We are in this building here, and there's this contour line going around us. So if we followed, here's a contour line of geography. So if we followed this line, if we were riding a bike, we would neither go uphill nor downhill. If we go and we cross this line, we would be going downhill. And then here's a line that's going by Mulford. Here's a line that's going by the Chancellor's house. We would be going up 2 lines. So the lines never cross. They imply how high above sea level we are. And they're a set of points at the same elevation above sea level. People generally familiar with the topographic map? Yeah? Now that we have GPSs, they don't have topographic lines on them. So it's a nice thing about using real maps. So there's our first view of the lines. They slope downward. You're trading off between the two things. They cannot cross. It's impossible mathematically. So we're supposing that they will never cross. The higher line that you're on is a better line to be on. And generally, we think that they're convex. So they're going to go up at the edges. As you get a lot of good 1, you're willing to trade off more and more to get a little bit of good 2. So that's why we're saying they're curved. They're going to curve out at the edges. You're going to get saturated with good 2, and you might just want a little bit of good 1, so you generally don't cross the axis there. So let's put our points on here. Here's 2 indifference curves. I drew these. I could draw these by hand, but you saw how bad I was, so I'm going to have 2 indifference curves that are nice and smooth before I draw them. Our point A here. So this is some bundle that we could do that quantity. So here, just for example, this is like 0.8 of this good 2. And here it's 1.2. You don't have to write. It's just a general idea of like we're reading units off of a bundle. The bundle is like we've chosen this amount. So on another indifference curve, we would have point B, which has more of both goods. So therefore, it's definitely a preferred bundle. We're not indifferent to it. But interestingly, we can have a point C. And what we're going to say is the consumer is B is preferred to A, but the consumer is indifferent between B and C. We're on the same indifference curve. We're indifferent between those 2 bundles. So point C has a whole bunch more of this good here. But exactly the same amount of this other good, but the consumer would be happy, the same amount of happy or the same amount of utility at these 2 points. It's also interesting to say you could have a point up here, point D, and they're also indifferent between B and C and D. So D has a whole lot of this good 1, and it has less than point A. So D is preferred to A as well, even though it has less of this good 2. Point D is still on this higher indifference curve because there's so much more of the good 1 that's on this higher indifference curve. Yeah. This is a map of the consumer's preferences. We're saying this is a way that we're going to graphically represent the preferences of the consumer. Yeah, so we don't really know what people's preferences are. We're just assuming that if we gave them a choice, they could rank the bundles, and this would be a way that we would mathematically represent their preferences, just by ranking their choices. So yeah, this is all about preferences. And different people would have different maps. Different people, different market segments, you could say. Those. The 2 lines cannot cross, because that violates the mathematics that we started with. So if we start with point A and point B, so B is on the same indifference curve as here. So this would say that B is preferred to A. But then there's a point C that's indifferent to A, and C is greater than B, which would mean that C is greater than A. So it's like mathematically not going to work out. We can't have 2 topographic lines where we're at 300 feet above sea level and 350 feet above sea level. They have to all perfectly nest. They have to nest by definition. There's no way that they could cross. So the choice question is, let's choose a bundle that we can afford. Let's spend all the money that we have and get the most that we can. I want to spend $500 on a TV. I have to think about how many square inches and how many pixels and how many different attributes. I want to buy a laptop. I want to buy the most RAM and the most hard drive and the most, a whole bunch of different attributes that are bundled into a good that we're choosing. The consumer can choose any bundle up to the budget line. And the bundle on the highest indifference curve that we can get to is the preferred one. So we have these nested indifference curves. We're trying to get the highest level given the budget that we have. So let's say there's 3 points again. This is point A, point B, and point C. So here's the line that we can afford from the first part. This is the budget constraint that we can afford. And here's 3 indifference curves. Indifference curve 1, indifference curve 2, indifference curve 3. 3 points are on 3 different indifference curves. We can afford A and B. Those are the 2 that we can afford. We can't afford point C because it's above our budget constraint. We can afford point A, but we can afford more than point A. We can afford point B. And importantly, we would say this is the point of tangency. So we would select the bundle where the budget constraint is tangent to the indifference curve. Point B is the best bundle we can afford. And by best, we mean most preferred. And so we do that, and we're like, OK, looks like we're consuming 2.5 of this one and 1.25 of this one. That's the best we can get. All points on the higher curve are superior. All points on the lower curve are inferior. We can afford more than them. Yeah. Let me. So you can. Right, so on this indifference curve, there's going to be a point up here that's also going to be on the same indifference curve, and it will have less of this good. But it will still be preferred to this curve. So you can have less of one good as long as you have a whole bunch more compensating. So the answer is yes. There's a, this one was obviously more of both, but there's a whole bunch of different points. Answers your question, I hope. Yeah? There are infinity indifference curves. It's just a map of space. Yes. It's, so I'm going back and forth between like ways to think about it and math. So mathematically, there's an infinity choices. It costs more, yeah, to get there. Well, you'd be equally happy with these different combinations on line V. Yeah, even though that's worth more. Your happiness level is different than what you can afford. They're two different lines. The straight line is the afford line, and the curved line is your happiness level line. You can only afford certain combinations.
So you're equally happy at any point on one line?
On one indifference curve. You're indifferent between the bundles on the same line. It's a mapping of your happiness. Happiness is equal along an indifference curve. There's some things that you can't afford. Indifference curve has no regards to price. That's correct. It's just quantities. It's just how you feel about two quantities.
So for an indifference curve that has a point of tangency with one line, that point is the bundle length,
right? So we're going to say there's a single point of tangency between this continuous curve and a straight line. That point of tangency is going to represent the highest indifference curve you could get to without amount of money. OK, we'll work through this some more. Don't give up. Now I'm lost as to where I was because I got all right. Oh, let's think about income. So as we said before, and you worked through the example, when income goes up, the whole line moves out. The slope is the same, but you're going to get to higher indifference curves as income goes up. And what we talked about in the last class was normal and inferior goods. So when income increases, if it's a normal good, the quantity of it would increase. If it's an inferior good, when income goes up, the quantity of it is going to decrease. So here's just a way to do that graphically, where here's two budget constraints, budget constraint 1, budget constraint 2. They're the budget constraints are the, I'm so messy with this, but our budget constraints are shifting out as income goes up. And as income goes up, we're going to move to a new bundle. So if this good here would be the normal good, and this good here, it looks like it's inferior good. As our income goes up, as we have more money to spend, we buy less of it. So this is showing graphically that concept of normal and inferior goods. So there's a whole bunch of nested indifference curves, and they can actually map out different directions. They don't have to just be. So what this is showing is like our indifference curves are moving down to this slope. They're not just like